Hello there, it's Jay here from Jay's Vintage Junk, and today we are back on with the old Quad 303, see if we can find out exactly what's happening with it, see if we can actually get it going again. First off, I will apologise for the rain noise, but there's not a lot I can do about it. It's actually a welcome change because it was absolutely sweltering in the workshop when I first started, and just as I started doing this filming, the rains have come, so it is cooling it down a little bit, but you will have to put up with a little bit of rain noise. So what I thought we would do is, I'm not happy with these old caps. I mean, they're probably not causing the fault, but seeing we're in here anyway, I'm going to swap out these electrolytics here because I know they're not a very good long-lived electrolytic. I'm sure they were fine back in the day, but I mean they're well over 40 years old now, so they're getting a little bit tired. So we're going to pull them out and replace them on both boards while we're in here, so literally so I don't have to do it again. Then what we're going to do is going to replace that resistor there, because I can't find anything wrong with the transistors, the diodes, anything around here which would actually cause that resistor to burn up. It's slightly strange really. I was expecting to find a shorted transistor or something like that. So we're going to change that resistor, and we're just going to put a normal quarter watt 10 ohm resistor in it, because these are all quarter watt, these little ones that were original, so it's not a power resistor or anything. We'll stick a modern one in there. We'll connect it up to a speaker, and we'll wind it up on the variac and see what happens, and we'll test for temperature on the transistors and things like that just with the finger, and we can test if one's getting overly hot or anything, and it may be suspect, it may be breaking down under load, but under the tester's conditions it's absolutely fine. We won't know that, like I said, until we're getting on into doing that. It is the dirty approach to repair this. I'm sure some proper engineers will go absolutely crazy about me trying to do it this way, but it's the way that I know how to fault find, so I think we'll get on with it. So we'll whip these caps off first, and we'll replace them. Now let's see what we've got. We've got minus going down there, sorry, we've got plus going down and minus going up. So you always got to remember to polarise these capacitors. So yeah, so that's the ground rail there at the top. We'll start with this 470. What else to add? Yeah, I've got a nice hot iron here. We'll have to add a little bit of new salt to that just to help it flow. Let's give that another go. That's more like it. Alright, let's have a go at that, see if that's come free. It's free on that side. Just help it out with the iron, I think. There we go. And that's a 470. That's at 10 volts. Now, unfortunately, I've not got any identical ones, but these are okay value-wise. One's rated at 25 volts. That one's that's a Rubicon, and that's rated at 35 volts. But they're both 470 UF caps, and they're both just over the 10 volts that the original was. So there's no problem putting these in there. Just a shame I didn't have two exactly matched ones, but I could always change that in the future if I really want to. So we'll stick that in there like that. Bend the legs out slightly to hold it in position. Yeah, and that'll fit fine. There's nothing underneath obstrude, because obviously it's a little bit longer than the original, but there's nothing underneath there getting in its way. Just solder that in position. Like that. I need my little legs box. Put my legs box there. And where's my snips? Snip. That's the first one changed. Right, let's do the same one. We'll do both boards together. I've got another 470 cap out here, so in fact we'll put that one in because it's the same voltage. I actually had 3. That one's a little bit shorter, but it's the same voltage, and I'll keep the higher voltage one for another day. See, it's only replacing a 10 volt. It doesn't matter too much. They're both 25 volts then, rather than 125 and 135. Again, I'll have to just add a little bit of fresh solder because that's not flowing very well. That's better. Right, hopefully that should come out. I'll just have to help it with the soldering iron. There we go, that's out. Put that to one side, I'll just clean some of that crud off. And put the new capacitor in. Okay, that should hold it. Right, where's my solder gone? I'll have to get some. Oh, there it is. On the floor. That Andy's solder fairy had it then. Okay. There we go. And I think we'll do this, which is the 10 UF at 63 volts. Next, so have we got some of them in stock? Get the capacitor box out. Ooh. Oh, they're not going to be any good. They're only 10 UF at 35 volts, and we need 10 UF at 63 volts. Let's see if we've got anything else. We may have to leave that one. I think these are all rather larger UF. They're like 220, something like that, so they are no good. Well, that might be a bit of a bummer. Again, I think these are all somewhat higher. I don't know what that is. Oh, it's only 35 volts. That's 47 UF. 22. I think we may have to leave that one, folks. I'll have to order some 10 UF at 63 volts. Yeah, no, this one we've got a 47 UF at 40 volts, and I'm pretty sure I've got some of them. Let's have a look. 47 UF at 50 volts there, okay. We can change that one. Just a bit of a shame about the 10 UFs, they're going to have to, I'm just going to have to shut my window a little bit, folks, because the rain is actually coming in. Dear me. Rain splashing on my Commodore 64, which is never good. Right, so we're going to have to leave these 10 UFs for now, unfortunately. What I might do is I might just whip one out and just quickly test it on the capacitance tester and just see what it's reading at. Out. There we go, it's out. I'll test that on the capacitance tester and see what it says. That's not good, it's coming out as a diode. try it the other way around, just in case the tester got confused. Ah, there we go. Cap 2 to 3, 15 UF. So it's meant to be 10, so I don't think it's entirely happy. Let's just try it around the other way again. Yeah, it's coming out as 15 UF and it should be 10 UF, so I think that's fairly well goosed, to be honest. We need to find some 10 UF capacitors then, that's the problem. 10 UF at 63 volts. I don't see that I've got any. Just bear with me, folks, I'll be right back when I've checked some of my other stocks. Okay, I've come up with something I'm going to do just for temporary, just so we can get on with this, and I've got some 4.7s at 63 volts here, so I'm just going to connect two of them in parallel, and that'll do for the time being. It'll do for at least this initial testing anyway. So negative up, same as the other one. Hopefully these holes are big enough to take two of these. It's not the ideal solution this, but it will get us by. At least just for testing. Like I said, and then I'll go through and I'll probably replace these capacitors again. But as you can see, that I couldn't put that one back in, not with capacitance quite that different, because it's obviously it's on its last legs. A little bit tight. The other one's gone through, so it can't be that bad. Was that hole a bit blocked? There we are. We won't go all the way down, obviously, because we're what we're doing here, but that'll do for initial testing. I'll solder them in position. So, I mean, we've used two capacitors, but they've got the right voltage rating, they've got the right capacitance, so that'll have to do for the time being. There we go. I may as well do the same on this board here as well and change that one out. That's out. So we have to do exactly the same. Oh, I'll just have to clear that hole out. I think that one's alright. Okay. Whew, God, it's a bit warm in here now. That rainstorm's finished. Just open the window. Again, hope it doesn't start raining again while I've got it open. There we go. That was definitely welcome, that blast of cool air. Right, so we're on to the last of the electrolytic capacitors we want to change. So these are 470 at 40 volts, and I've got some 470s at sorry, these are 47 at 40 volts, and I've got some 47s at 50 volts here to replace them with. So let's get them out. What's them ones there? And that's out. It's negative to the bottom. That goes in like that. Push that home, and the legs out to just hold it while it's there. We can solder that one in position. Excuse me a minute, folks. Let's see who this is. Nothing important. There we go. So that's that one done. I'll do the same on this board here. Just swap that one out. That's them two connections there. There we go, that's that one out. Put that in there. So okay. Yep. And let's just solder this in place. There we go. There we go, so that's any of the capacitors which will be causing issues. So it's not ideal we've had to use two to replace that, but it'll certainly do for testing, it'll do for the time being. Then I will change them out at a later date for just a single capacitor. Right, now time to change that resistor. Now I've got two choices here. I've got these beauties. Now these are XMOD, and they're very nice, very high tolerance, but they're about a watt, and you don't really want to replace a resistor with a bigger one, because some resistors in some stuff is really acting a bit like a fuse. They've used right on the tolerance, because that will burn out rather than something that's more critical like a transistor or something to burn out in a fault condition. So ideally you don't really want to replace them with anything like that. So we'll just use a modern little 1/4 watt resistor. I mean, it's far smaller than the original, but that is that part. They're both rated the same, they're both 1/4 watt parts. So we'll stick one of these in, and then we'll have a look at winding this thing up on the variac and see exactly what happens, whether it smokes or not again. And if it does, then we're going to have to try and figure out what is making it smoke, which is, like I said, slightly odd. It must be, in that case, it must be something that's failing under load. Get in there. Okay, now that's in position. I can solder that in position now. Ouch. just snip that off. There we go. So what I'm going to do is I'm going to connect this up to just the left hand channel, just the channel has been causing issues to a speaker. I don't know, it's not going to be safe. They are going to have to be down like that while we test them, unfortunately. Purely because I don't want anything to short out. That one's okay like that. That one, is there some way I can prop it up so I can see what it's doing while it, yeah, I might be able to prop it up like that. What I don't want to happen is the wires on the back to short against the chassis, because that wouldn't be good. I do have, that should work. Yeah, that's going to work alright. If there's nothing there shorting out, yeah, I think that'll work. Oops, until I move it. So we want to connect this to the left hand channel. I've just got a crappy old Sharp hi-fi speaker. It's a test speaker. It's nothing special, it's just that thing there. And the reason I'm using that is if it blows up, I don't really care whether it damages that speaker. That's where I have my LS3s connected and it damaged the speaker, I'd be absolutely mortified. So that is why we're doing it like that. Now I need to find an IEC lead. There should be one kicking about down here somewhere. Why do they always go missing as soon as you need one? Not that bad. Must be this one. Yeah, there's one. So we've got an IEC lead. Plug in an IEC lead like that, and we'll connect that to the variac. We'll turn the variac right down, we'll plug that into the variac, and then we can power this thing up slowly and see what happens. Right, so that's what we're going to do. So I'll put the variac on, and we seem to have a hum from the speaker. Now we're under 100 volts there. No smoke so far, but we do have a hum which I was not really expecting. Now, where is my input lead? Hopefully we can just use a resistor or something and touch the that. Let's try the other side. This should be the side that's working alright. As we're here, absolutely silent. Oh. Now that's the good side. I'll go over to the other side. Bear in mind this is on severely reduced voltage. I mean severely reduced voltage. I've only got the amp running at probably about 80 volts. That's interesting, that's the same input as before. Now that side, I'll just switch off for a second. Let's get our continuity tester. Let's see if that is definitely the side which is causing issues. Should we go from the input which is there? Let's get that down onto continuity. Let's go onto the input which is there. So I'm not getting anything. Let's try switching it on and let's see if we can get a hum by touching the connection there. Yeah, there's plenty of light there. The other side. Hang on. It's absolutely silent. That's got plenty of power there. Nothing there, which is good. But when we move over onto this side, you can hear that hum. But there's definitely amplifying. So I'll switch off again and let's feel some of them transistors. See if anything's getting overly hot. And nothing feels overly warm. No. Very odd indeed. Strange thing is that the new resistor that I've put in is also staying cold. Let's try it again and let's just bring the voltage up a little bit. I don't want to go too silly daft on it, but we will just perhaps just bring it up. In fact, let me put my little switch off again. I'll put my little stand in like that. Now that's at 100 volts. There's certainly something definitely wrong with that channel. It's amplifying fine, it's just we've got that that hum. I wonder if I should check the main smoothers on that side. It may be that there is a fault with the smoothers on one side after all. Just bear with me, I'll just switch that off. I'll just give it a sec to let the capacitors discharge. If it is, then this is going to have to be put to one side for a little bit while I can get some new capacitors for it, because these capacitors are rather expensive. Now how's this wired? Do we have two per side? I'm suspecting that's how it's done. Let's see which wires go where. Now that's got yellow and white and green and white on it. That's green and white there. Got the same green and white, yeah, it looks like it. And yellow and white will go to the front, won't it? Yeah. So it's the other side, I think. Green and red. Yep. So let's test this this capacitor here. So we'll desolder that wire off it, and we'll check it on the capacitance meter. It should be 2200 UF. Better just short it just to make sure there is no charge left on it. I don't want to blow my tester up. Shouldn't be, but just to be on the safe side. It can take some time for that's coming up okay. 22,042. So yeah, it's pretty close that. So have we got a leaky transistor somewhere? Could that be the problem? Where it's not exactly short circuit, but it's on the leaky side. That's certainly a possibility. What we could do is we could swap these boards over. I think that might be easier than swapping the transistors over on the back. We could swap these boards over and see if the fault moves to the other side. That would that gives us an idea whether it's the fault's on the board or it's on the power transistors. I'm not 100% sure which it's going to be. So anyway, I'm going to whip these boards out. I'm going to swap them over, and we'll see if the fault moves with them. So I'll be right back as soon as I've done that. Okay, let's have a rethink. I've not swapped them boards over yet. I've had a thought. Let's check some voltages. Well, I think what we're going to do is we'll power it up on the reduced voltage, and we'll just test the voltages here we've got compared with there and with on the working board, and see if we've got any discrepancy there. This is really puzzling me, this one. We need a good ground point, so I think the chassis is grounded on this. Yes, it will be, because the grounds on the transistors go to it. So we'll ground to that. We'll set this to let's set it to 200 volts DC just to start off with. We're not going, no, it can't be. We'll set it to 20 volts DC. That should be enough. If we obviously we go over range, then we go over range, and we can always address that. But let's don't worry, that was a thunderclap. Let's see what we've got here. That's obviously over. So we've got 34.5 volts there, and we've got 34.5 volts there, so that's okay. We've got 10.8 volts there, and we've got 11.9 volts there. Okay. We've got 10.4 volts there, and we've got 11.5 volts there. Right, so we've got a little discrepancy there. We've got 10.4 volts there, and we've got 11.5 volts there. So this seems to be a little bit higher. We've got 10.4 volts there, 11.5, I think I've just done that one already. We've got 0 volts there, and we've got 0 volts there. We've got, that must be a ground as well, 0 volts there, and 0 volts there. So I think I supply voltage in 34.4 volts and 34.5 volts. Yeah, that's close enough. It's these next ones which we've got the issue. We've got, like I said, 10.8 volts on that side, and we've got 11.9 volts on that side. So there's certainly discrepancy there. Now let's have a look. That's the ground from that transistor. Just there. Switch that off again. So what could be causing that discrepancy in voltage? I know it's only a volt, but on something as precision as this, a volt can make all the difference. The thing is that these transistors aren't warming up at all. And they're cool on the other side as well. I wonder if I need to wrap the voltage up a bit more. And I was planning on swapping these two boards over, but I'm trying everything else beforehand, really. I don't want to have to swap them over if I don't have to. Let's try giving it a, perhaps I'll put my little test thing in so I can see what's happening, and I'll just crack the voltage up a little bit higher. Still watching what's happening. Nothing's smoking yet, we've just got that hum. I can't see anything smoking yet. I'm up to right, we're at 150 volts. So we're still well off what the amplifier is designed to run on. But yeah, I still don't see anything trying to smoke yet. I'll just let it run for a minute at this voltage, then I'll try testing the tops of them transistors again. But the amp does run. It's just got that background hum now. I'd have expected that resistor to at least be getting a little bit smoky at this point, even though we're 100 volts off what it should be running at. And that doesn't sound particularly distorted either. I can smell something getting a little bit warm, I must admit. I can't see anything smoking yet, and that resistor isn't discolouring yet. Let's hope we can get a transistor to get warm, and we can perhaps find it that way. Although every transistor I've pulled out so far seems okay. It definitely doesn't sound bad. It's weird. Instead, if I swap over onto the good working channel. Absolute silence. I think I may actually have to bite the bullet and swap these two boards over to try and isolate the fault between the board and the rest of the amplifier. I was trying to avoid it because there's so many connections to make, and I don't want it to make it look messy, but we'll keep this running. We'll just run this at this higher voltage for a minute or two, and then we'll I'll go around the faulty board with my finger, and we'll see if we can find that way of finding where it has got a bad transistor somewhere. mean, we can be pretty confident that the capacitors that I've put in are alright, because I mean they're all new ones, and they are fairly recent ones. You know, it's not the ones that have been standing around for years in my storage. But the main smoothing cams, I can't see them being the issue either. I don't think they're at fault. That one certainly come up fine on the tester. I could test the other one as well. Right, let's switch that off, and we'll have another quick. Ooh, there's definitely something held to charge in there. What? No. No, nothing feels like it's got hot. It's really strange. I really don't have to desolder all them to swap these two boards over, but I don't think I've got any other choice. And that's the only. Like I said, if the fault flips to over here, then we know the fault's definitely in the board. If the fault stays over on this side, then we know the fault's going to be in the power transistors or in the smoothing cans. That's all I can really think of doing now, because it's turning into a bit of a bugger, this one, really. It really is. Right, so I will be back shortly when I've figured out what I'm going to do. Okay, and I'm back, and as you can see, that was a right pain in the backside to do. I've swapped the boards over, so this is the suspected faulty board, and that's the board that was working okay. And let's see if the fault's now changed from the left channel to the right channel. In fact, first thing I'm just going to clean up some of my solder there, just make sure I've not got anything bridging anything that I shouldn't. You can see a little bit of solder stuck to the old flux there. Let's just make sure they're nice and clean. We don't want any shorts. I think that side's alright. Yeah, I'm happy with that now. Now, I haven't got the inputs connected, but that shouldn't matter for the moment. All we're interested in is whether the fault has moved from the left channel to the right channel. So I'm going to connect this up to the left channel again, and we will see whether we've got nice silence or whether we've got that hum still there. I'll get the alright, I'm still running this on reduced voltage. It's still only on 150 volts on the variac just for now. So let's switch on. And I hear no hum. Let's give it a prod. And I hear absolutely no hum there. So that rules out the transistors, and it rules out the smoothing cans on that side. So let's go over onto the faulty side, which is now the right hand channel. And oh, I hear no hum. Now that is strange. Let's just well, that's most odd. Yeah, moving the board over from that side to that side, and it's gone. We seem to have cleared the hum. Now that really is strange. Right, bear with me. I'm just going to, I'll pause you again while I connect the inputs up to the end of this. And we'll just try it with it all as it should be. And then we'll try it on full voltage and see what happens. So back with me very, very shortly. Okay, I'm back. I've gone and got the input lead for it. I've got the inputs reconnected onto the two boards there. And I've got all the boards back down in position. And I'm going to connect the speaker up to the left hand side again, and we're actually going to wind this thing up on the variac up to its proper voltage. But that's on at 150 volts. Absolutely nothing. What have I done wrong this time? Oh, it does help it really does help if you actually plug the IEC back into the device you're working on. So let's try that again, shall we? So let's plug the IEC in. Let's switch on. Now bear in mind we are picking some noise up from the fact the cable's not grounded there. So let's try on the other side. Same again. That sounds quite promising. So I think what we will do, let's plug that into my tablet. Right, that's plugged into my tablet now. So we can turn the volume down on the tablet because we don't want to destroy these speakers. I think we can. It's complaining about batteries, the tablet at the moment. Use batteries, sod it. We'll turn the volume right down, like I said, because we are. There we go. Yeah, I think this tablet's on its last legs. The power connector started to plug up on it now. I'll have to hold it like that, I think. And what I will do is I will increase the voltage back up to 250 volts. And we're there now. Sorry, 240 volts. We don't want to go to 250. So the amp's now running at its full 250 volts. And I will try, if I can, to play some music through my tablet through it. So I don't know how long this is going to last because the tablet is not charging properly now. I'll have to replace this one, I think. Let's try that one last time. If you push on the power connector for it, it does work. Right. Okay. Get off that. Let's get some music up. That's the on the right hand channel, which was the channel which we put what we thought was faulty board on. We'll swap over onto the other channel. I can't play too much of this music because literally I got hit with a copyright strike on that mixing desk video I've just done. So we will just keep this really brief. My apologies, you know, I'm trying hard to take it back. So if by the time the bar closes and you feel like falling down, we'll go on to the other side. So I think we definitely still do have a fault. Right. But if we actually unplug, if we unplug there, you can hear we've got absolute silence. It could be just a really biased song. That. Let me try a different song. Let's find something else. Let's try this. And put that back in. Either that or it's the. Let's try the other side. So we still definitely have a fault on this channel. But we seem to have got rid of the buzz that we had before. And we did that just by swapping boards over. Anyway, I'm going to stop that. I think this is going to... oops, let's unplug that. Yeah, it's just picking up the buzz from the cable, that. So I think we've definitely... This is going to turn into a three-pointer, I think. And the good point we've got rid of that hum. I don't know. I think that may have just actually been a dry joint on one of these connections, because all I've done was swap the two boards over, and that hum has disappeared. But that's the left-hand channel. That's the channel that was making the horrible buzz. And I said we've swapped the boards over, so the capacitors and the main output transistors on the left channel are definitely absolutely spot on. They're fine. If we move over onto the right channel, again the hum has gone. It's not there anymore. But we don't seem to have as much power in this channel as we do in that channel, so there's still definitely a fault that we need to trace out. That sounds okay there, but let's compare that with the other side. So that's a strange thing, that. When I inject a signal like that, that sounds exactly fine. Wonder if it's that crappy cable I was using. Because when I inject a signal like that, they're both exactly the same volume, but when I was trying it on the... in fact, that's what we could do. Let's try that one more time with the tablet. And I'll try swapping the phonos over on the tablet and see whether it changes. So, we'll plug that in there. This is just to rule out whether it's something with my crappy cables which is causing the problem. We'll plug that in there. We'll start this playing. And what we'll do is we'll just... I think we found the problem. Yeah, the fault's not that, it's this crappy connector that I was using. Oops. In fact, let me stop this. I'm going to just go and find a better cable and we'll actually try and do a better test, because obviously we do have cable issues here. It might actually be working now. Let me just go and find a new better cable. Okay, I have indeed found a better 3.5 cable here, so let's try that again and see if we get the same symptoms. I'll unplug that from the power because we're only going to do this for a minute. Right, let's try this again. Okay, so that's one side playing. Let's try swapping that over. How's that? So it was just the cable I was just using there causing that problem. So it looks like we fixed it. So I think what we had is we had a dry joint. So that sounds now, each side sounds exactly the same. We'll try advancing that on, so I don't want to get another hit with another copyright strike. Move that over again to this side. And it's exactly the same volume level. So, let me just stop that now and let's turn the variac off. Like I said, that's running at mains voltage now, so that is running at its full voltage. What I think I'll excuse me. What I think I will quickly do is I will reassemble this, and I'll give you one final play of it down. Stop my tablet as well. I will reassemble this and I'll give it one final play down in the office, connected up to the mixing desk, so you can actually hear it how I wanted to show it last time when it decided to misbehave on us. So we'll be right back once I've got this thing put back together. Okay, we're down in my office here, and I apologise for the lighting. The camera really doesn't like the lighting in here, even though I have updated it. As you can see, we have the Quad 303 there, and you can see the power's on. I've got it connected up to my tape recorder and the mixing desk, and I've got that. In fact, just bear with me. I've just realised that the tape isn't threaded up on the machine, and I can't do that with this handheld. So I'll be back very, very shortly. Just one sec. Okay, sorry about that, folks. I just had to thread up the old tape. I've just threaded that Gilbert and Sullivan up so we've got something to play through this, that hopefully the copyright won't grab us for, because they didn't do on the Gilbert and Sullivan last time. So let's get that playing. Let's let the leader roll play through. Okay, now we should get something on the desk if we bring the level up. Hopefully this will start in a second. There we go. So that's playing through my LS3s there. It's just a bit hot, that. That's playing through both sides. I can't play it too loud at the moment, unfortunately. It's getting a little bit late. But as you can hear, the quad is now working very, very, very nicely. Let's listen to the other. And they were playing the other side of that. In fact, I've got that on the wrong channel. Just 1 second. Let's try that again. There we go. That's a bit better. Just give you an idea. So it definitely is working. And the other speaker on that side's working as well. It's only mono recording this, but because we've got it going through the sound desk and we're balanced, it does come out through both speakers. So that's it, that's the Quad 303 repaired. Like I said, it was a bit of a strange one, that. I think it was possibly a dry joint has caused that resistor to, over years, to go high. It finally failed. When we replaced the resistor, we still had that buzz. When we swapped them boards over, we obviously cured the dry joint. Just turn that down a bit. The reason it wasn't coming up too loud before, I was turning the wrong phase. I'm still getting used to this desk, and I was changing. I've got it connected into phones, unfortunately, rather than the master out when I plugged this up before, and I was turning the wrong fader there. So it goes very loud. It's 45 watt amplifier, this, so I do have to keep it down a bit when I'm using it. But you can get an idea of the quality you can get from it. Anyway, I'm going to leave it there for now, because this bit's going to be a bit dark anyway. There's not a lot I can do about that. I'm going to have to upgrade the lighting in my office somewhat before I can make some proper videos in here. But I thought you'd like to see the amplifier fully working and back in position. So I will say thanks for watching and goodbye.